yeah, I think this was the last thing that we looked at over here. So while this is building, we can probably just talk. We were talking about cons lists and pattern matching. So like with cons lists, you can do pattern matching like this, where you can safely get the tail, or sorry, the head of a list or the tail of a list, and not have to like be concerned if you get this nil thing, which would in Haskell, for example, cause this thing to blow up. So cons lists are pretty cool, and I'm sure that we're going to use cons lists in the future to do like a bunch of pattern matching. What do we build? On page 89. Here we go. 89. So we have arrays versus lists. So the one thing we learned, I think at the end of the day, is that you can only match lists, or sorry, arrays like perfectly. So you either know the whole list or nothing about the list, but you can't know parts of the list like you can with a list. Sorry, they're all lists to me. It's just how they behave. But arrays aren't particularly good with recursion. They're more like JavaScript arrays. And so yeah, we would have to use a different tool to get this done. Okay, record patterns. So let's stick these in here. I'm a little worried these are going to paste in really strangely, but we'll see. That's fine, actually. I wonder if I can... Nice. I should really use dot way more often. It saves a ton of typing, and I'm just not particularly good with it. All right, so just a reminder that these are like type aliases for records. They don't have constructors. The way you construct them is just by building up the record with these particular keys. And so that's how you do it. Okay, so let's look at a bunch of different ways to write a function to check to see if an employee is a CEO. Okay, so we have an employee. I assume that we're checking their job title. Let's just write the function ourselves. So I think that CT, so is CEO, maybe we just do this, is going to take an employee, and it's going to return a Boolean. Is CEO is going to look for... I think that you can literally just write job title. I'm guessing, by the way. And then say job title equals CEO. And then is CEO otherwise is false. False. Okay, so it seems to think that this is not possible. So I wonder if instead we say something like this. No, I'm just guessing. So anyway, it says that that's a warning. So this isn't quite right, apparently. All right, so the naive way... Wait, this is okay? How is this okay? I actually don't understand how this works. Does that actually compile? Oh, I'm being silly. Sorry. An employee is not like a record of things, different things. Like it only can ever have a job title. So, I thought like I would have to deal with company and address, but I do not. I'm just being goofball. So yeah, I do recall this. We could also use obviously this record access syntax, which is nice too. Um, yep, and we can pull these things out. Cool. Is this row polymorphism? No, not yet. We don't even have like these aren't row polymorphic types yet. To make them row polymorphic, you need like something like this, and then like an R. I think. I think it's like this. Yeah, and I don't exactly remember how they work, but I know that they get talked about in the book. So this is really just like record puns or field puns, I think is what they're called in Haskell. I don't know if you have those in Idris or not. I assume that you do, but I don't know what they're called. Okay, cool. So with this one, we have an address and a state. So you can see like if we want to see if it's a California state, then we first pick out the address, and then we use a oh wow, okay, that's interesting. Field puns are really nice for what it's worth. I know it's an extension. Okay, fair enough. Like if you're not doing a ton of nested records, I guess it's probably not that useful. But yeah, so here's another one of those field puns, but the outside pattern match is like a more traditional pattern match. So like we could literally write, for example, X if I could type, and then change this to X if we wanted to. That's like the sort of more traditional pattern matchy style of this, but the sort of the field pun style is job title, which I definitely prefer because it makes life a lot easier. And also it's saying like, oops, I don't really care about the other fields in the employee, which is nice. But yeah, I'm not going to write the is California one because I hope that it's clear what's going on. I just kind of wanted to show the connection if I could. All right, is company, is employee. Okay, so here is row polymorphism as it turns out, which is kind of like in a different style. So if we have a company or an employee, we want to know if they're California or in California, but I wasn't expecting to see them so soon, if I'm honest. So you can say, give me some record that contains an address and other fields. I don't care what those other fields are. And then pass me a Boolean. So it's kind of funny that this comes up as soon as it does. I'm happy about this, actually. And then you can just pull out the state from the address like so. And then state, not Virginia. Okay, so we could do this. Another option that honestly may be nicer is just to do address.state like that. I don't know. I want to show different ways of doing this. I can't decide if this is better in this particular case because you lose like the colon and an extra set of curly braces. I think that this is pretty readable if I had to guess. So yeah, this is row polymorphism. So this is saying like I don't care what is in there as long as it contains an address, and both the employee and the company can contain an address, so we're good to go. I think we talked about this for all last time, but the R just means like and other stuff in this case. You can also we saw it before in like function signatures and stuff for polymorphic functions. And it's required in PureScript, whereas it's not required in Haskell. But there's a semantic difference to how they behave in PureScript. Cool. Yeah, so it says that we have a record with at least a field name address, but we don't care what they are. Yep, I just said that. And the technical term for R is a row type. More on this later. there's one more important thing we can do, and that's rename a field parameter. Yep. So we could have done this as well. I feel like this reads quite a bit easier than this one. It's starting to get pretty syntax heavy for me. So I kind of like just removing as much as I can there. Yeah, and then we could literally pattern match out this string if we wanted to, which I think this is a cool option as well. I think I like this better personally, but you know, it's cool that you can also do this as basic pattern matching. Okay, cool. Any questions on this? Everybody on the same page? Row polymorphism is pretty sweet. All right, so logical control. So if then else, case, more pattern matching, and guards. So I always forget about guards, and they're like incredibly useful. So there's if then else is very interesting in these functional languages because there's almost never if else or just an if. Like it's always if then else, and they have to be that way. And this goes back to like what's the term? I'm losing the term in my head. But like any pure function has to be defined. So you have to return something in both branches. Otherwise, this wouldn't be a pure function, right? If we just had an if statement, then we would be, I don't know, like performing an effect or something. So you can't have int to int. Yeah, I think total is the right term. Yes. If we only had an if statement and we didn't have an else statement, like this function can't make sense. It's impossible to do this. So if you want to perform effects with like ifs, you tend to use like when. There's a monadic construct called when. I don't know if that's in PureScript, but it probably is. And that can only happen inside of an effect, which would make sense because it's the only way you can have a when statement is in a non-total function. Okay. Well, I guess that doesn't necessarily mean it's non-total, but you're performing a side effect in certain cases only. Anyway, yeah, if we didn't have the else, in JavaScript there's a similar if expression. Yep, that one, which is basically all you get in PureScript. Okay. It's funny how I know it's coming next. I think I've read a few of these books before. Mm-hmm. Yep. Perfect. Yeah, that's kind of what I expected. So case expressions are literally my favorite things. I can't think of something more enjoyable than pattern matching combined with a case expression. It's what makes functional programming fun for me, if I'm honest. Okay, so I don't think I actually need to type this in, but if we had this enum type or sum type or coproduct, I recently learned that it's called a coproduct. We could have like a phone or email or fax, and that's how we're going to contact a customer, for example. If we want to keep modern, is kind of a weird function, but it's like only use modern contact methods, I guess. So if we had a fax, use email instead. I don't know. It's kind of a weird thing to do, but the point is the case expression. So preferred contact method is a contact method, so it can be one of these things. And so we can say case this of like a bunch of things and then pattern match on them. And you could do something like this with a Boolean expression as well. Although I think in most cases, the if then else is preferred in these cases. But it's not a big deal. Okay. Actually, just because I'm thinking about it, in um, in Unison, there's an yet another construct called cases, which just allows you to like remove the case blank of, and then you can literally just write like cases phone like this, blah blah blah, which is really cool. And we were talking recently about like or I was thinking recently about stuff that I would include if I had a language, like if I was writing a language, and I think this would be one of them, a cases statement. And actually, I think I would really want to just remove case of if possible and like make every function cases. I don't know if that's possible, but I think that would be interesting. I actually really love programming with cases. Anyway, it's not available in PureScript. It's just something I found interesting in Unison. All right, so we looked at that. More pattern matching. So this is another similar pattern matching method. So instead of using case of, we use, like I don't know what you would call this. Maybe the Haskell style. Maybe is this, I don't know. I don't know what this would be called, but essentially this is like another way to do the pattern matching. I tend to prefer the case statements now, but you know, it's hard. I don't know if there's actual true lambda case in PureScript. I actually kind of want to look that up. Lambda case PureScript. Used the wrong finger. Oh, is there just case underscore? I kind of want to try that now. So can we do? I certainly don't want to grab that, but if we do case, sorry, keep modern, is going to take a contact method to con. Man, still getting used to this keyboard. Does this compile? Oh, okay. So we do have lambda case. It's just like a slightly different version. And I think that you can only do this with like one thing. But yeah, I tend to prefer this style over this style now. I used to write this more often. So yeah, so it's interesting. He says this is slightly easier to read. And I would actually argue that for me, this is easier to read now. So I don't know. It's definitely subjective. Okay, and then there's also guards. So guards are also kind of similar in this case. So like we could write, I'm just gonna write the exact example here because I think it would be useful. Um, let's put a prime here. Contact method to contact method and keep modern. Then we could say like contact method, and then you could say well, I guess this is awkward because you don't really need this syntax here. Maybe there's another example here. Oh, okay. So yeah, they're adding guards additionally. So this is kind of funny. It wouldn't make sense to do this actually. Ignore me. That's my bad. I'm getting ahead of myself. But this actually looks pretty nice to me. We could do like we could take an age and then say case underscore of, and then do age less than 40, send them an email, otherwise send them a fax. Although I would argue maybe that's not true anymore. I think it's very rare that people use fax anymore, but that's not the point of the example, so it's not a big deal. All right, so yeah, again we have this arrow here, and then we can like guard on other things with the same case. right, what's this one? So here's another examples of guards. Yeah, no bigger than 10. Okay, cool. This is sort of a weird function, generally speaking, but like that's besides the point. Again, we're just looking at these guards, which are really useful when you have combinations of pattern matching with some Boolean type expression. All right, so here's the take while function. So we have some predicate with a list, and we're going to turn another list. So we say pattern match out the predicate, pull out the head and the tail, and then we'll say wait, this is weird. Where's the equals sign? Oh, no, it's right here. I'm totally blind. I'm sorry. I highlighted the equal sign. So here's the thing that's saying, is this true or false? If it's true, then do this. Otherwise, you're ending. So this is a recursive function that uses a predicate to avoid like an if statement, essentially, which is nice. Does this make sense? I don't know. We're gonna do a ton more recursive stuff. So, like, we're pulling the head, and then if the predicate is true, include the head. Otherwise, don't. Basically. Okay. All right. Let's keep going. Yeah. Okay. So here's an example. X equals 1, xs equals the rest, and then we include it, etc. Okay. Predicates. Maybe this isn't familiar, but that's just the term for some sort of expression like this, something to Boolean. All right, lambda functions. Lambdas are pretty useful. I'm pretty sure like every modern language has lambdas now. I can't even think of a programming language that doesn't have lambdas. I'm trying to, but I can't come up with it. I mean, there must be one, right? Okay. Anyway, so here's a lambda function. It's just like take this x and return this thing on the right. I'm not really a lambda calculus person, so there's like, steps for binding variables to this lambda expression, but yeah, it's essentially just a function with some inputs that are curried for you, if I remember correctly. So here's a f that takes an int. This isn't necessary. You could just do this, which is probably what most people would do. I think that there isn't like a 0.3 plus one. I don't know. I'm kind of curious if that's true. So f int f equals plus 1. Does this compile? No, it does not. So I don't think there are what are these called? Sections in pure script. So you have to use more of the sort of either this syntax or this syntax to deal with this. Okay, so here's a filter. And then yeah, so there's the automatically curried stuff for you. Like so. Okay. So there are times when functions have more parameters than is specified in type signatures. This can be really confusing when you first encounter this, but taking into consideration lambdas can help. Let's examine the compose function. Usually its binary operator is this. So this is, I usually say this is after. So if you had like F and G with like Let me just write it so it's less confusing. If you had this, you say this in English, F after G. So G comes first. If you write it this way, then it's F before G, I guess. I don't use this function very often, but it's forward composition instead of backwards composition. The forwards composition, I think, is more familiar to most programmers, but if you start doing Haskell a lot, you see the compose function more, this after. Yeah, and you can see it here. So it's like G before F, or F after G, something like that. All right, so we specified 3 parameters here. What's up? Function. Okay, f of g of x is of type C, which does not match the return value in the type signature. What's going on? It turns out that this function is equivalent to writing it with a lambda. So we could write it this way, which is basically an A to C function. So really the type of this x here is just this A. Okay, cool. Yeah, and all of these are equivalent. You can move everything as you please, as long as the operators and precedence work. So that's cool. Alrighty, what next? Let's see here. We've answered the question about the number of parameters, but let's return to our original conundrum to see another way to look at this. F of g of x is of type C, which is not what the return value of this function shows. Remember that type signatures are right associative. Yeah. So we could rewrite this as this, and then now we have 3 parameters, or like what looks like 3 parameters anyway to a human being, and so the world is happy again. Okay, wildcards. So far we've seen underscore used as a don't care variable. There are other times it's used as a wildcard. Oh yeah, so we talked about this earlier, and yeah, I said that this is probably how I would write this function. So case of is basically a lambda of like some variable to case x of. So like this can just be expanded as x to case x of. Like those are equivalent here. So I'm comparing this to that. They're the same thing. And they make writing some code a lot easier. I'm trying to remember if you can do multiple ones of these or just one. So yeah, point free notation. This allows underscore to stand for the second parameter. It's still a don't care variable since we don't name it, but we use the value in this case. Yep, so here's the example. Wait, there are operator sections. Oh, okay, we just used them with underscores. Okay, so in that example I showed earlier, you just use an underscore, so it would be like times 1 or whatever, and that's how you deal with. Well, I can't do it this way, but I can do f equals, and then it will not complain. So in Haskell, you can write this, which is a section, but you need to use an underscore to deal with sections as well. Cool. That's good to know. So, sections. That's important to me because I like using sections. Okay. Wildcards can be used in records. So you can, oh, that's cool. So this is a function to build up a record with a name and an age. That's pretty sweet. I think I've seen this a few times, but I've never really used it. But that's pretty useful. And you can do, okay, so you can build the record and you can also do record update syntax this way as well. So that's cool. So if you want to update just like 2 fields in some person, then you can just do that with this syntax, which is cool. Or if you want to, oh, that's neat too. So if you want to say like, you could, okay, I want to write this function because I think this is kind of interesting. Um, so we could say, I don't know, G I'm going to call it. What am I doing? Okay, so we could say for all rows, give me something with an age that's an integer and other stuff. Now, what do we return here? I guess we return. Sorry. We return age, int, and the other stuff? Let's see if it works. So it would be like underscore age equals 18. Does this compile? Very cool. So that's pretty sweet, actually. Like, I don't think you can do this in. Like, I don't know what languages make this really easy in a statically typed way. But like, you could say, you know, this is like set age 18. And that would work for any record with an age field. I guess you could also take an integer of like and just say set age, and then you don't even have to like deal with this. So if we took an int and then, you know, just said n, that's pretty cool. That's a nice function right there. All right, very cool. All right, so this is some stuff that I haven't really messed with, so it's nice to put this in here. So let's call this actually operator sections require underscores. Row polymorphic records, record updates. That's cool. All right, next. What time is it, by the way? 8:30. Cool. Bindings. We have two ways to bind variables to values to variables. Sorry. Don't forget, functions are also values in functional programming. Yes, first class functions. Okay, so mult sum. Okay, so we're just demoing the where and let syntax. So we have we're generating some tuple of these integers multiplied together and then added together. And we have this where syntax, which allows us to bind local variables. So mult and sum are local only to this function, and so we can use them here and here as, you know, values, just like that. Okay. Yep, and yeah, it's private to the function, so they're local. Yeah, and like one thing that's important here is, you know, if you're gonna name these things, you better name them well. I think that like if this was me, I would never do this. I don't think. I mean, I know that it's an example, but you can just inline these and it would be probably more readable. But you know, we're just demonstrating. Um, yeah, this is one of these weird things where here, let me actually like you're gonna get strange errors here because we're think that this is gonna give me more or less what I need. Okay. Um, Okay, so wait, what? Wait, did I define a tuple in here somewhere? Tuple? I did. Okay. Um, so let's call this like that, and then that way we can just do the following. Okay, and then that shouldn't complain. So there is some weirdness when you want to do something like this. You're gonna get like these weird parsing errors. And so a lot of times what I'll do is I'll just tab them out until they stop complaining. You have to write in this case, and then just use like a formatter. Oh, well, I don't have a formatter right now, but just use a formatter to fix the syntax because it's kind of annoying. So like these tab and space sensitive languages can be a little annoying in that regard, but I don't know. For me, it's way better than having to deal with so much syntax in the way. So yeah, anyway, if this is past apparently this S, it will behave as if it's attached here, which is nice. Okay, so there's another syntax. This isn't usually how I would write this, but that's fine. There's a let syntax, which allows you to bind stuff up front instead of afterwards. And I think, depending on who you are, some people prefer this. I don't know. Maybe this is like a good poll. So if this was me, I would probably write. Oops, wrong button. I would probably write it like this. So stylistically, usually people align the T and the N, and then align everything like this. Um, again, subjective. If you want to write it this way, it doesn't matter. It's the same exact thing. Okay. So unlike where, which must be a part of a named function, let can be used in any expression. Yeah, so let is just an expression, which makes life a lot easier. So let is a more powerful tool than where. And actually, I think I prefer let in most cases. Now that I'm thinking about it, I'm curious. This is definitely a good poll to ask. Um, I got to think of a like a minimal example, I guess. Maybe this multiplication one is pretty nice. Um, yeah, okay. So line continuation is similar to where apparently. That's totally fine with me. Um, I find this reading this is kind of weird to me, but I guess it's like this is the return, this is the thing, like the value that you're actually interested in. So maybe that's kind of the logic for putting the in there. Is like it's kind of like here's the block and then this is what it returns. So it almost looks more like do notation, I guess, in this style. Kind of interesting. I've never seen it in this style personally. Okay. Binary operators. So we've seen binary operators and actions, but we failed to define them. Binary operator is an operator represented by a symbol that is a function of two parameters. Okay. The value on the left-hand side of the operator is the first, the value on the right is the second. So here's append, where we have a list on the left, a list on the right, and we're combining them basically. And then we define a binary operator, like infix binary operator for append. Oh, hey Subi, this is interesting. Let's all right. Let's see if there's. Is there more, or is that the only? Oh, I need to look at this book. You've been putting these together. I need to check out some of the ones that you have. But this is interesting. Cool. Yeah, I think like for me, this is pretty nice. In this particular case, I think this is maybe it's a little too far indented, but or wait, no, it's just two characters indented. So I don't know. All right. Yeah. So anyway, you would break line after let. Break line after let. Which line? You mean like that? Oh, like this. Probably. Ah, I keep pressing the wrong button. Maybe like that? Is that what you mean? Cool. Yeah, I think I'm okay with this too. Like this doesn't bother me at all. Um like if my formatter did this, I wouldn't be mad. And I'm not a person that gets fussy about format. Like I would rather just bring in a tool to do the work for me. So like if I had this or the one I showed before, like either of these are suffice to me. Yeah, I they do that in Elm a lot. So in Elm you'll see like I think it's more like this actually in Elm, for example, with I think four space tabs or four space indentation instead of two. I think it's more like this anyway. Yeah, I think that's too much space for me personally, but you know, I would be fine with this or the one where it's to the right of the let. Okay. Anyway, back to binary operators. So this as is like binding append as this binary operator. So this will only work for two parameter functions. Um, and this infix r is like, I think there's infix r and infix l, and then this is like a priority or something. So the lower number, the more priority it has. I I always have to like think very carefully about this stuff because I don't use this a lot. I think it's more popular to use in PureScript because people define more infix functions. In Haskell, a lot of them are already defined for you, so I don't really have to think about it. Um, but I would like to understand these better. So maybe we're going to talk about precedence a little bit. Yeah, precedence is the term I said priority, but precedence is the term I'm looking for. All right. Anyway, append will append. We know that. We know that. We know that. Defining the operator, the semigroup operator as infixed right associative operator. So infix, obviously, and R is right associative, and with precedence 5. So this is the part that I think we're going to talk about now. Okay. So there are three types of associativity for binary operators. Right associative, left associative, and none. I've never experienced none. I don't really know what this means yet, so I would have guessed that they have to be right or left, but maybe there's a good example of none. All right. So the operator append, it's like the semigroup operator. I'm not sure, like they call it mapend, but I would guess you just call it append. One second, I gotta sneeze. I don't think I have to sneeze. Maybe I have to sneeze. We'll see. Anyway, right associative means this goes first, and so you can draw the implicit parentheses in this way. If we have left associative operator, the stuff on the left comes first. So you can think of this as like fold from the right, fold from the left. Right associative, left associated. And it does matter in certain cases. It doesn't matter for plus, but all right. The operator equal equal is non-associative. Okay, cool. Here's an example of non-associative that I didn't really think about. Oh, okay. So like, yeah, like what how would you pick which one of these comes first? It doesn't make any sense. So when you want cases where you have to define the precedence, you would use none. Okay, that's cool. I guess I hadn't thought about this that carefully, but that's a great example of non-associative binary operators. Okay, so the multiplication operator has a precedence of 7, whereas the plus operator has a precedence of 6. Okay, so it's just basically PEMDAS encoded in a number system. I wonder if there's. I had it backwards also. Like I said, lower is higher. It's the other way. Larger number has more precedence, which I guess makes sense. Um, but anyway, I wonder if there's like a cleaner way to write this. Like precedence of 7 is kind of, unfortunate, I guess. Like I don't know if there's terms for this stuff is what I'm trying to say. It might be nicer if they were termed in a certain way. All right, so in our append function, we specified infix r5. That means it's evaluated before any other operators that are part of the same expression that have lower precedence. Yeah, that makes sense. How does one pick this number? Like, I would guess that most binary operators are going to be 5, except for arithmetic operators and the sort of equals equals. Because you would probably want to do, like 2 times 3 append. This is a bad example, but we'll use append to be plus, and we'll put an append here. We would want 2 times 3 to happen before we try to append 4, and we'll just assume that pluses them. I know there are 2 integer semigroup operators. So I guess that makes sense, which is, in this particular case, it's more obvious because, like, this is sort of plus, right? Like, append and plus are pretty similar operations. Okay. Fixity. Infix means infixed operator. Yeah. Yeah, you could like test, you could write some tests that like do some weird stuff and then, choose which one you want based on that. And I guess like there are certain cases where you could make like the reference between your operator and something else. So like, is this supposed to be like multiplication? Then maybe you choose the same precedence as a multiplication operation. Is it supposed to be like addition, which the semigroup one is? Or don't define them. That's fair. You don't have to. I do like operators in a lot of cases. So, but again, you can always use this syntax, so you don't really need to worry about it. And there's also this syntax, which is probably used more often in Haskell for sections, because you can. So in Haskell, you could write something like, L1, for example, but you can't really do that in you can't do that in PureScript. So the way you would do this is you would write, well, it's the other way around, but you would write L1 underscore if you wanted to like say do an operator section. So arguably it's more clear in PureScript like how these work. Maybe, I don't know. I like the point free syntax in Haskell, so I think I'm biased. Okay, cool. Yep. So anyway, we can always get around it like this, as Supi pointed out. So you don't have to worry about it. Yep. See you, Subi. Thanks for hanging out. Appreciate it. I gotta go to work soon anyway, so only got a little bit more of the stream left. I'm hoping that I can finish this chapter. I don't know how much longer it is. All right. So yeah, so this infix operator alum must have higher precedence than the sort of the syntax around it, which makes sense. I think this if and then would be evaluated last in this case, so it probably has the lowest precedence. It's not a binary operator, obviously, but like the expressions inside will be evaluated first. Okay, comments. There are comments. Nice. You can do multi-line comments like this. I think I have this tool called commentary, which does comments for me, but the block comments are just done in this style and not this style. So it is what it is. I've not messed with PSC docs before, but that's cool. All right. Inferring functionality from type signatures. All functions have type signatures, whether defined explicitly by the developer or determined implicitly. Best practice deem that. Oh, this is like yeah, determining best fit for certain functions. So if we have a function f int to int to int, right? There's only a certain number of expressions that you can do. Like there's only a certain number of things that you can do to make this happen that makes sense. So as an example, plus, multiplication. There's max, min, add, subtract, divide, etc. But if you have a function like this one, there's actually only one function that is a valid version of this, and it's the identity function. So you can't put anything else in this. I think I already have F, so we'll use H. For all A to A. Identity, I believe, is what it's called in PureScript. So you don't know anything about this. You have no idea what it is. So how can you modify it? Well, you can't. That's like the definition. So there's literally only one valid version of this function, and it's identity. So, this one has a lot of different implementations, and you could think of, I don't know, probably like hundreds, but I don't know that it's infinite. Maybe it is infinite because you could just say like, put these together and then add. Well, if you enforce that it can only be a binary operator between them, then I guess maybe it's not infinite. I don't know. You could just write weird functions, I guess. So, yep. So here's the only function that has that signature. And then there's also this other function. So here's another weird example. And I think there's a way to deal with this one as well. A to B. And if I recall correctly, it's called absurd. Maybe it's not absurd. Hang on. Okay, absurd is different. What is absurd? Oh, this takes a void and tries to like. Okay, absurd is different. I can't remember if there's a function that does this. That it's basically just bottom. So like you could just write error. Like that's a valid implementation. Well, it's not error, whatever it's called. I guess from 2. So wait. Oh, but this makes an effect, so it's not. I think you would have to say effect. And then are we good? What's the type? Could not match type effect with type function. Okay, anyway, my point is that you can't you can't implement that function. It's bottom. There's no way to do it. Okay. So if we have a function like this, maybe head or tail, we've seen those before. Maybe what else could we do? Is empty? Now that wouldn't make sense. Non-empty is like make non-empty list, for example. Well, no, but it's still maybe A, so that doesn't work. Anyway, Um, I can think of head and tail. Oh, tail isn't right either. Yeah, it has to be last. What's const index? I don't know what const index means. Three, tries to return the element at some hard-coded index. Oh, okay, that's fine. Like, always get the first index or something. Or, well, not the first, but the second. Not sure. It turns out that first and last are just special cases of const index. So, for all practical purpose, there's only one unique function with this type this type signature. Can we write this function? I think the answer is no. There are no total functions that can be written with this type signature. We can, however, write partial functions, but it will crash. Yep. All right, what about this type signature? Yes. So this is valid because you could say, like, if the thing is empty, return A. So you can do like a bunch of stuff. Or this could literally just always return the first element, which is const. So always first, always last. Const is another example of this function. So that's an interesting type signature, I would say. Const is a less interesting implementation, but it could be a valid type signature. Let's look at this one. A to int to list AA. Yeah, we could definitely do stuff with this because at worst we have an A. So this could be like index of, where we give it an int to look for that index. Otherwise, we return an A, something like that. Yeah, get at, for example, with a default. Okay. Yeah, the details are not important. It's just like, can you think of these things? I think I would be interested to hear if people find this particularly, like, I think this kind of stuff is interesting to think about, but I wonder if like a beginner they have enough FP to like think about this stuff. I don't know, maybe. So this looks like our get at, but it's missing. Why is this? What would you put in place of question in the following? It would be maybe A. Yeah. Oh, this is interesting. Um, let me write that one down. I'm trying to like write down as many errors as I can find. So this is on page 110. Page 110. First code block. Get at prime uses the wrong tick mark. Okay. Cool. What time is it? 8:57. We're almost done. Or well, I gotta go to work, basically. Okay. This may seem pretty complex, but it's actually not. Um, so we give a default A, and we apply this function if there isn't an A present at that location. So that's basically probably the only reasonable implementation for this function. Like, because you have this, you have an A, and you have a list A. Like, how many ways can you put this together to form a B? Well, there's really only one. It would be like get at map. I wouldn't call this convert personally, probably just map. Or map at, even, might be fine. I thought we couldn't have a function from A to B. What gives? No, you can totally have a function from A to B, but you need an A. We can't have only a function A to B, which we saw earlier. Okay, cool. When we call this function with int to string, yeah, this is just like going through the explanation if you need it. You need to have an A to make a B in this case. No big deal. And we have an A, so it's fine. All right. We should have enough information. In between. Yep. Yep. This is actually a cool chapter. Actually, I when I first did this kind of stuff, and like you kind of just see how the pieces fit. Like you have these puzzle pieces, and you could really only put them together in one way. There's nothing you can do. Um, this is interesting. What would this do? Given two A's, return an A. You can either return the first or the second one. Based on some internal criteria, what could that criteria possibly be? I think the answer is like there is no internal criteria. It's either const or flip const. I think those are the only two valid implementations for this function. Oh, I guess you could just return nothing. So that gives you some flexibility, but like you don't know what A is. So I don't fully understand what this one means, but anyway. So we have a predicate, an A. So like if this predicate is true or something, then return just, otherwise return nothing, for example. Cool. So summary. We learned a lot in this chapter about some of the basic parts of PureScript, from types to common language constructs. There will be more to come, and while theory is important, getting some hands-on experience can cement that theoretical understanding. Oftentimes we blah blah blah. Okay. Um, you'll probably find yourself returning to this chapter as you work out the coming exercises. Exercises, yes. That's my favorite part about books. Now it's time to get our hands dirty. Cool. So, installing PureScript. I guess we should talk about this next time because it's it's a lot easier now, I think, because you just do this. And so we'll talk about this next time. I already have PureScript installed, but we can talk about the various ways that one installs PureScript, and I'll provide like another tool that, or another way to get this thing that you don't need. You don't even need npm for. You could just use Nix and get this stuff pretty quickly. So for those who actually care about Nix. All right. Anyway, that's it for me.